This training video is intended to be used by a TxDOT electrical inspector as an inspection aid for a Type T electrical service. Other resources available to the inspector are the latest edition of the National Electrical Code and TxDOT's standard specifications for construction and maintenance of highway, streets, and bridges. The inspector should also have the plans, TxDOT's electrical detail ED sheets, and any special provisions or specifications for the job to be inspected. Let's begin with an important note. "There's too much work and not enough time" is a phrase we have all heard at one time or another. While this may be true, we cannot allow it to result in unsafe work practices by cutting corners or eliminating safety steps. Remember, safety is a requirement, not an option. Now, let's get started. A voltmeter should be used to determine the absence or the presence of electrical energy before conducting an inspection on any piece of electrical equipment. A Type T electrical service uses a very basic electrical enclosure. Unlike TxDOT's custom-built Type A electrical service, the Type T electrical service uses a 120-240-volt off-the-shelf galvanized load center. A Type T service has 6 or fewer branch circuit breakers. Because there are 6 or fewer circuit breakers, the National Electric Code does not require it to have a main circuit breaker. The Type T electrical service is designed to be used when the load served will primarily be traffic signals. When safety lighting is to be controlled from a Type T enclosure, a pole-mounted or luminaire-mounted photocell can be added. Safety lighting that is powered from a Type T service will be controlled in one of 2 ways: a photocell physically located on top of each luminaire, or a photocell mounted at the top of the service support structure. On the diagram of a Type T electrical service on ED6, we see service's load center is identified on the legend as number 14 in the diagram. This is outlined by the broken dashed line around the bus bar and branch circuit breakers. Let us begin our inspection by looking first at the load center and its internal components. Departmental Material Specification DMS 11080 Electrical Services and DMS 11084 Electrical Services Type T lay out the specifications for this enclosure. To summarize these specifications, a Type T service uses a galvanized steel weatherproof enclosure, a UL-listed load center, has 4 to 6 breaker spaces, has copper or aluminum bus bars, and uses full-size plug-in breakers. At first glance, we might think this completes the Type T specification, but DMS 11080 also specifies requirements for all services, which include labeling. The front cover of the load center must have a danger high voltage label, an arc flash hazard label, a label identifying the load served by the service, and a unique service ID that matches the electrical service data chart from the plans. DMS 11080 also allows that when a label with 1-inch high letters is too big to fit on the enclosure door, then smaller-sized letters may be used. The Type T electrical service uses a basic type of electrical equipment called a load center. The load center is a manufactured panel board that comes in standard sizes and is used to distribute electrical power throughout a site. Load centers come in various sizes, with slots for plug-in circuit breakers. A 225-amp load center may have as many as 42 slots for circuit breakers. A breaker that fills a single slot in the load center is called a one-pole breaker and will provide power to a 120-volt circuit such as a wall receptacle or a traffic signal cabinet. A breaker that fills 2 slots is called a two-pole breaker and will serve a 240-volt load, such as a luminaire mounted on a traffic signal pole. The inspector will need to review the plans and find the electrical service data chart to determine the exact number and size of 1- and 2-pole breakers to be installed by the contractor. It is not necessary for all the load center slots to have a breaker installed into them. DMS 11084 requires Type T services to be provided with a minimum of 4 and a maximum of 6 breaker spaces. When a Type T service provides power for a signal intersection, the 120-volt traffic signal control cabinet will use 1 space in the service for a single pole breaker. When the signal intersection has a light fixture operating at 240 volts, they will use a 2-pole breaker, which takes up 2 spaces. A single pole breaker will turn power on and off to 1 conductor, and a 2-pole breaker will turn power on and off to 2 conductors. Breakers also protect the conductors of their circuits from being damaged by short circuits, ground faults, and overloads. Breakers in a Type T service have a push-in and pull-out feature commonly called plug-in or stab lock. This allows the breakers to be replaced easily. When a breaker is removed from contact with the bus bars, the breaker and any conductors connected to it are de-energized, since the power comes from the bus bars. During the inspection, the inspector will check that the breakers have been properly and fully plugged into the bus bars. A quick shake of each breaker will alert the inspector to any breaker that has not been fully seated, as it will appear looser than the others. Each branch circuit breaker will have a label showing the required torque value for the conductor connection to the breaker. This should be checked and verified with a torque screwdriver to make sure each conductor has been properly secured to the breaker. At this point in the inspection, the inspector will review the electrical service data sheet in the plan set, verifying that the quantity and size of the branch circuit breakers matches the plans. Note that for a Type T service, the electrical service data sheet will not show the size of a main breaker, since the Type T does not have one. The NEC allows services with 6 or fewer branch circuit breakers to have no main breaker. This allows for a simpler and more economical service when only a few circuits are needed. Notice in the schematic diagram that only 1 bus bar is provided for both the grounded conductor and the grounding conductors. The grounded conductor in a Type T service can also be called the neutral conductor. The diagram shows the equipment grounding conductors, marked G, the neutral branch circuit conductors, marked N, and the neutral conductor with a white insulation from the meter, are all connected to this bus. Notice the short line going from the bus to the enclosure wall. This is the main bonding jumper. The NEC defines the main bonding jumper as the connection between the grounded circuit conductor and the equipment grounding conductor, or the supply-side bonding jumper, or both, at the service. For many manufacturers of electrical services, this conductor is not a conductor at all, but is a fine threaded machine screw. This screw is painted green by the manufacturer and is called the main bonding screw, or jumper. When inspecting a Type T service, it is very important to confirm that the green bonding screw has been installed. If the bonding screw is not installed, then the service's grounding path will be incomplete. If a ground fault occurs in this condition, then the branch circuit breaker may not open to protect the circuit, potentially putting the public in danger. If the inspector finds the bonding screw has not been installed, he should inform the contractor immediately to correct it in the interest of public safety. The NEC requires that the circuit directory in the load center be filled in with a complete description of the load served by each breaker. The NEC requires that this be done with a permanent ink pen that will not bleed or run if it gets wet. The inspector must confirm the circuit directory has been completed. It is a simple task for the contractor, but is occasionally overlooked. Now, let's discuss the mounting of the Type T service. All service equipment is mounted to a support structure, either a granite concrete pole, a steel frame, or a treated timber pole as specified by the service data in the plans. In this project's electrical service data chart, the design engineer has specified a steel pole service support, designated SP. The NEC provides us with several references when mounting electrical equipment, so let's look at them. The NEC states in Article 110.3, examination, identification, installation, use, and listing, product certification, of equipment, that mechanical strength, durability, and other factors must be considered. Article 110.3b says equipment must be installed in accordance with any instructions included with the equipment. The NEC also tells us in Article 110.12 that all electrical equipment must be installed in a neat and workmanlike manner. The NEC further guides us in Article 110.13a that all electrical equipment is required to be firmly secured to the surface on which it is mounted. Instructions for mounting electrical enclosures on a timber pole are on ED 10. Material requirements and mounting methods are specified in the notes. The inspector should inspect the mounting of a Type T service enclosure and meter base using these guidelines. Are the enclosures and conduits installed plumb, square, and level? Is the equipment rigidly mounted and immovable using moderate force generated by one hand? Are the fasteners durable and made of the proper materials? Were the manufacturer's installation instructions followed? The answers to these questions will indicate how well the contractor has complied with the specifications and plans. The next item that the inspector should check is the location of the laminated as-built drawing called for in ED 5, Electrical Service Notes, Notes 13 and 14. Often, the Type T service enclosure is too small to hold the as-built documents, so contractors may place them in the traffic signal cabinet instead. If these drawings are not included on the project, then the inspector will need to inform the engineer and the contractor of this non-compliance. A complete set of documents required is outlined on ED 5, Note 13. Now, let's move on to voltage readings. Before power is applied to any electrical equipment, the following voltage measurements should be taken at the service by the contractor and recorded in the presence of either the project's engineer or inspector. Reading number 1, line 1 to line 2. For a 120-240 volt system, the voltage check should show approximately 240 volts. Reading number 2, line 1 to the neutral or ground. This reading should be approximately 120 volts, or 1/2 of the previous reading. Reading number 3, line 2 to the neutral or ground. This reading should be the same as line number 1 to the neutral or ground. If no voltage or a lower voltage is recorded for this reading, then it is likely the service has not been properly grounded. Should any of the readings be outside of the ranges shown, none of the breakers may be turned on. The serving utility must be contacted and changes made until the readings are within the correct ranges. Failure to confirm that the voltages are within specifications may result in damage to the connected electrical equipment. Once the issues have been corrected, the inspector should confirm the service enclosure is padlocked with a master lock keyed to 2195. This completes our review of the inspection tasks for a Type T electrical service.